question. 7.1, question 8. Okay, what do you notice for part A? Show that angle ABC equals to 90 degrees, right? How should we go about showing it? Okay, I hear Pythagoras theorem. Is that the complete one? Then I hear the word converse. So what's the difference between these two? Let us go back to basics. What does your Pythagoras theorem state? Okay, Pythagoras theorem, you might want to copy this down because this is a popular question that will come out. Okay, Pythagoras theorem. For Pythagoras theorem, this is what we have. One right angle triangle, let's call it A, B, and C. So for us to use Pythagoras theorem, what is the condition that is required? What 90? What is the condition? A triangle must be a right angle triangle. So for a right angle triangle, come in. Okay? The condition for Pythagoras theorem is it must be a right angle triangle. And what do we have? AB square plus BC square equals to AC square. Right? This is our Pythagoras theorem. What? I'm talking about question 8, exercise 7.1. Okay, this is our Pythagoras theorem. So if I want you to prove that there is a right angle in this triangle, can I use Pythagoras theorem? You cannot, because Pythagoras theorem has a condition. The condition is it must be a right angle triangle first. So I cannot use Pythagoras theorem to prove that there is a 90 degrees. Instead, I need to work backwards. I need to reverse direction, right? So what do we call this? We call it converse of Pythagoras theorem. Okay, now what does the converse of Pythagoras theorem state? Okay, so let me draw a diagram. Let's say I have another triangle, A, B, and C. Did I state any of the angles in my second triangle? I didn't state. So we don't know any of the angles. I don't know whether any of them is 90 degrees or not. But if I want to prove it, I will need to use converse of Pythagoras theorem. And this is how I'm going to do it. What's the commotion over there for? What's the commotion about? Nothing, huh? So you're ready for lesson? Yes. Converse of Pythagoras theorem. If the square, okay wait, if the sum of squares of two sides equal to the square of third side. Okay, in this case, let's say if AB square plus BC square equals to AC square, then, so i.e. that is, if AB square plus BC square equals to AC square, if this is fulfilled, then I can conclude. And what do I conclude? I conclude that angle ABC is 90 degrees. Okay, it is a reverse. You must know the difference between Pythagoras theorem and converse of Pythagoras theorem. Who doesn't see the relationship yet? Anybody? No? Then let us go and look at question 8a. Okay, in exercise 7.1. Don't worry if you haven't finished copying, because this is going to be uploaded anyway. So exercise 7.1, question 8a. We have a diagram. Okay, A, B, C, D. This is 65 units, 33 units, and 56 units. Now, based on the diagram, did they tell you any angle? They didn't, right? But what does part A want? They want you to show that angle ABC is 90 degrees. Let us try to identify this angle. Where is it? ABC, or over here. Okay, that is what they want you to show. Can I start off with by Pythagoras theorem? Can I do this? Why cannot? Yeah, because earlier we said for Pythagoras theorem to be used, the condition is there must be a right angle inside the triangle. And that is what they want us to prove. So how can I state by Pythagoras theorem blah 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 blah? I haven't proven it yet. Yes, so what we should be using is converse of Pythagoras theorem. And you remember what that means? We have the reverse, right? So what is my first working that I should show? Ali, what do you think I should show first? What is the first step that I should do? My final step is to show that angle ABC is 90 degrees. So in order to do that, I am going to apply converse of Pythagoras theorem. So what is the first thing I need to calculate? The rest of you think also, huh? $65 square. Okay, hang on. So Ali is saying that we should find out what is AC square, which is 65 square, right? Okay, let's punch it into our calculator. What do we get? 4225. Alright? Okay, he has shown us, he has suggested the first step. What could be my second step? Keep in mind, eventually, I want to use converse of Pythagoras theorem to show that angle ABC is 90 degrees. So what should my next calculation be? Yes, Afiq? 33 square plus 56 square. Now, working is correct, but I don't like this presentation because what is this 33? What is this 56? No, I don't need to write so much. Look at the step before that. What did I write? Okay. AB square. So I know AB is 33, right? So plus BC square equals to this. And what are we hoping to find out when I press calculator? What am I hoping to get? 4225. That's what I hope, huh? So go and press, see what you get. What did you all get? 4225. Does it look familiar? Okay, where have we seen this? What is this supposed to be also? It is also AC square, isn't it? So what have we now proven? We have shown that sum of squares of two sides, which is like what we have said also, AB square plus BC square equals to AC square. So therefore, AB square plus BC square equals to AC square. Okay, I have this relationship now. How do I present my work then? Okay, Alfian, say it louder. Just now what do you say? No, I heard you say. Bye. By converse of Pythagoras theorem, then angle ABC equals to 90 degrees. Okay, this is how you present, and this is how you show the difference between using Pythagoras theorem and using converse of Pythagoras theorem. Then you see that this portion over here, ABC equals to 90 degrees, that is actually given in your question 8a. Okay, so just put down, shown. Wait. One more time. Okay, what are you suggesting? equals to 56 square then AC square equals to 65 square equals to 4225. Okay, basically it's the same lah. You are just reversing these two steps, right? Yeah, then okay lor. Huh? Okay, show me your paper later on. Later on, after the lesson, okay? So if you have done this, it is fine also. Just reversing only. Okay? Any other questions for this? Otherwise, I want to go into your homework 7.4. 7.4, I asked you all to bring today. It is on your cosine rule. Okay, I will just start with question 7. Not always they will provide you with the diagram. Okay, like your question 1 and question 2, they gave you a diagram. So as part of your homework, question 7, I gave you a question without a diagram. So what is the first thing that we should do? Sketch the diagram so that you can visualize and you know what belongs to where. Okay, so A, B, C, and then A is 8, C 7, angle ABC 50. Okay, so angle A, B, C, this angle is 50 degrees. Then they also, okay, A equals to 8 centimeters. In your question, small a, which side is that referring to? Right, which side is this 8 cm? Where's your textbook? Okay. Question 7. Which side is 8 centimeters? BC over here, 8 cm. And how do we know? Because they said that this is small a. Okay, and we have said before, the angle, big A, will be opposite small a, which is the length. Then we have small c, which is 7 cm over here. And they ask us to find the side, B. Okay, so this must be B. Right, so how should we do this? We can find B first, yes. How do we do that? B square equals to plus C square. Oh, okay. So that's not the end, alright? Okay, because this is incomplete if we are using cosine rule. But when is this true? It is true only when it is a right angle triangle. That's when you have your Pythagoras theorem. Okay, but since they didn't say it is a right angle triangle, we have to continue. B square equals A square plus C square minus cosine B. Okay, and so we have seen 3 different variations of our cosine rule. Basically, it's just the letterings. All the A, B, C, you must know where they belong. So when I want to find the side B, my angle will also be B. Okay, this is the pattern that you'll notice as long as you use your cosine rule frequently enough. Okay, so based on this, I can substitute in numbers. What I will have is B square equals to 8 square plus 7 square minus 2 times 8 times 7 cosine 50 degrees. Now, from here, how do I save a step? So, yeah, I'm going to find square root, right? So I don't want to write the whole thing again. I will just remove this. Just put a square root over here. Okay, and just make sure your calculations are all correct. You should arrive at the correct answer. So try it on your calculator. 8 square. What do you get, Sophia? 4037 How many SF do we want? 5 is enough, right? So let's leave it like this. This is a 4. And I need to round it off, right? 6.40 cm. And I need the 0 because I want 3 SF. Okay? So that is finding the side B. And next, I want to find angle BAC. BAC. B, I've already found it. This is 6.4037. Okay, so from this point onwards, I should hear different suggestions on how to find angle BAC. Yang Kun, give me how do you find angle BAC? Sine. So just sine. Sine. Have you done your work? Huh? Haven't. So when are you going to show it to me? After school today. So you're staying back up. What time are you showing it to me? Sorry? 3 o'clock? Okay. So now you think, how am I going to find angle BAC? Cosine rule, okay? I cannot just write down cosine rule. You must tell me what to write. I mean, I'm not going to write this. And then answer. Cannot be. Tell me what to write in. So am I supposed to write down a formula? So what do you want me to write? Cosine B equals to A square plus minus B square. Huh? What? Wrong already. Why wrong? Okay, listen. This is what Yang Kun suggested at the beginning. But before he finished the formula, he told me wrong already. Do you know why? Okay, Afiq, can you share? Because we are trying to find angle BA. We are trying to find angle BAC. Then what's the issue? So you cannot just directly apply whatever is stated in your textbook, letter for letter. You need to know which angle you are interested in. Okay, now Yang Kun, this angle we want is BAC, right? So instead of calling it angle BAC, short form, what do we call it? Angle A. So what is the formula for finding angle A? There are 2 ways you can go about it. You can start from your cosine rule, or you can use what Yang Kun tried. Cosine A equals to blah 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 blah. Either way is fine as long as you are careful. So Yang Kun, what do you think? You want to start with cosine A, is it? Sure. Okay. So cosine A. In other words, this cosine A is cosine BAC equals to what? B square minus plus or minus? Plus. Continue. C square minus A square over 2BC. Okay. If you choose to memorize this, it's fine. For me, I didn't memorize because I don't want to memorize so many things. I will derive it. And I've shown you how to do it in the previous lesson. I will derive it if I'm sitting for the exam, if I'm sitting for the test. Because I don't like to memorize so many things. But fine, he wants to use this. Okay, so we can now substitute. And B square will be 6.4037 square plus C, which is 7 square minus 8 square divided by 2 times B, which is 6.4037 times C, which is 7. Okay, just substituting. But before that, you must identify the correct formula to use. Once you have this, what can we do? We're going to evaluate this, right? You get a value. Is that my answer for angle B? Angle BAC? No, this is the cosine of the angle. So last step. In the last step, I will need to find angle BAC, which is actually the same as cosine A. I need to cosine inverse whatever this number is. Okay? Once done, you get a value, put it in 3dp first, then you round it off. And it will be 1 dp as your final answer. Don't forget your units. Okay? Now this is one way to do it. What is another way to do it? Yes. I have Darren and Francis suggesting that we can use sine rule, right? We can. Let's look at the diagram again. These are the things we have. I have 3 sides. I have an angle over here. If I want to apply my sine rule, what will it be? Same question, Okay, now applying my sine rule. Francis, what did you have for the first step? Sine A, like that, over 8. Sine 50 over. Okay, now, does this look familiar? Or does this look familiar? So, which one look familiar? Dark blue or red? Red, right? Okay, but mathematically, is there a difference? Mathematically, got difference or not? Mathematically, no difference. Okay, let's look at this. Let's look at equation number 1. Okay, I am going to multiply both sides by 8. So what do I get? I get sine A equals to 8 sine 50 over 6.4037. Next step, I'm going to divide both sides by sine 50. No. I am going to divide times 8. Where? Now I'm going to times 6. From here to here, I multiply by 6. Then I get 6.4037 sine A equals to 8 sine 50 degrees, correct? It's just balancing the equation, or like what I have told you before, do the headshot thingy, do a cross. Then, my next step, I am going to divide by sine A. Wait, hang on. Wait. Confirm they are the same. 8 sine 50. Very confirm. So now I want 8 over. So I divide by sine 50 on both sides. Okay, then I'll get 6.4037 sine A over sine 50 equals to 8. Next step, I'm going to divide by sine A. And I will arrive at 6.4037 over sine 50 equals to 8 over sine A. Huh? You get it? So now this is the same as what I have written earlier on. 8 over sine A equals to 6.4037 over sine 50. They are the same. Okay? So yes, like what Darren and Francis suggested, we can use our sine rule, meaning this highlighted portion, to find the value of angle A. You have one equation with only one unknown. You can solve for it. Then, the next thing is, how am I going to find angle ACB? Class, how to find this angle after you have found angle BAC? Got at least 3 ways to do it. How do I find the purple angle ACB? Who wants to use sine rule? Okay, Francis wants to use sine rule. Who wants to use cosine rule? Okay, Sophia. Then the rest, the rest you want to use 180 degrees minus 50 degrees minus the blue angle lah. Not stupid. It is just, sometimes you're very fixated on a method that you want to use. Then you don't see the simpler method. The simpler method is sum of angles in triangle equal 180, right? Then minus lah. Okay? So that is for question 7. Okay, next one I want to discuss will be question number 9. Question 9, I have a diagram, it's a parallelogram. Okay, I'll just sketch it over here. A, B, C, D. Middle is E. Then they tell me this is 63 degrees. Alright, the length AC is 22. AC is 22. Can you tell me how much is AE, Winnie Wong? How much is AE? You are not Winnie Wong. Winnie Wong. AC is 22, so how much is AE? How did she get 11? She divided by 2 lah. So this is 11, this is 11. So Winnie, can you continue to tell me how much is DE? They tell us that DB is 12, so how much is DE? 6, excellent. So this is 6, this is 6. Now we are all set to find the length of BC. Okay, over here, BC. How to find it? So I'm going to highlight this triangle for you, make things easier. Okay, so how to find BC? Pythagoras theorem, okay. So what was the condition for Pythagoras theorem that we stated? Right angle, right? Wait, how is the right angle? Don't have, so cannot use Pythagoras theorem. Okay, so Sophia is saying cosine rule. Good guess. So what will I write for my working? Should I still write things like a square equals to b square plus c square minus 2bc cosine A? Should I do that? No, let's just skip this step because all the letters over here, all the letters, they may not correspond to the triangle I have. So, I'm going to show you how I'm going to write it. So my unknown side BC, I'll write it down first. BC square. Okay, this square equals to the other two sides, and we square them. So EB square plus EC square. Okay, so far okay? Then I need to minus 2 times the same thing over here. I see EB, right? So put down EB times EC cosine the angle that is opposite BC, which is 63. Okay? Okay. I tried skipping one step already. You can continue to skip some more steps if you want. So like what Rabiatu has, she will substitute in value straight away and she'll put a square root. It is fine. Now, what we have over here will be EB is 6 square plus 11 square minus 2 times 6 times 11 cosine 63 degrees. This is BC square. And to save some work, I'm going to remove this and put a square root. Yes, the MPCC students can go. Make sure you watch the video, do your corrections, submit it tomorrow. Goodbye. Go quickly, go, go, go. So you get an answer for BC. How much is that? .8525 cm, right? Must have the units. Round it off, 9.85 cm. Okay, now I have BC. In my diagram, I want to transfer this answer over. Should I transfer 9.85 or should I transfer 9.8525? The more SF, the better. So 9.8525. Next part is to find the length of AB. Now I want to find this. I want to find this side now. How to find? Teja, what do you think? Huh? Cosine rule. Okay, what are we going to write? AB, this is part B. So AB with a square root equals how much? 6 square. Then cosine 117. Then how many of you have questions for this step? Nobody has questions. Then I'm going to ask questions, no? And I'm going to ask the one whose head is on the table. Ali, you think you're hiding behind Afi? I cannot see you, right? How did she get 117? What? Where? It's not in the question. $180 minus 63. So Teja, you need to show me that step first, or we can write it on this way. 180 degrees minus 63 degrees. Because I don't want to see unfamiliar numbers coming out from nowhere. And what is the reason for this? 180 minus 63. Ali, what's the reason? What straight line? You look at the diagram. This is the angle that they just said, 117. So how did she get 117? Why 180 degrees minus 63? So what is the reason we state? We state that adjacent angles on a straight line. This is the reason we gave. Okay? So get the answer. How much is it? What do y'all get? To be safe, you put it down, so I know where it came from. Just like your lower secondary, when you deal with all your angles, for example, alternate angles, for example, your interior angles or your supplementary angles, you always have to state reasons. So I would like to see reasons as well here. Okay, so moving on. What did y'all get for value of AB? 728. So 5 SF enough already, huh? So 14.7 cm. This is 14.728. Then last part, find angle ABC. Okay, so part C now. Angle ABC is over here. How do I find this angle? What have you learned? You learned your trigo, your torcaso, which is applicable only for right angle triangles. You have learned sine rule. You have learned cosine rule. So what can we use to find this angle over here? Which rule can we use? You only left with two options. Sine rule, cosine rule. Okay, let me make things easier for you. I will highlight this triangle. What do I have? I have three sides, right? I have three sides of a triangle. Yes, Zafira is correct. I shall use my cosine rule. Using my cosine rule, AC square equals to AB square plus BC square minus 2AB times BC cosine ABC. Substitute in all your numbers. So we have 22 square equals to 14.728 square plus 9.8525 square minus 2 times 14.728 times 9.8525 cosine ABC. So next step, you'll find cosine ABC is equals to something, then angle ABC must be cosine inverse whatever that is. Get the answer in 3dp. Then round it off to 1dp. Okay? Yeah, because angles we leave it in 1dp. Can? Shall we? Okay? Okay, now we are left with 10, 11, and 12. I would like to go through only two more questions. Which would you like me to go through? 10? C. Okay, the whole of question 10 plus one more. Which one would you like me to go through? I'm going through the whole of question 10. What else would you like me to go through? No preference, so I choose. Two questions only. Okay, 10 and 11. In question 10, I hope you are doing your corrections as I'm going through. Alright, find the length of BC. The highlighted region. How to find? Which rule? Cosine rule, okay. So I'm going to reduce my steps already. Instead of writing everything out, this one I'm going to write BC square equals to 5 square plus 4 square minus 2 times 5 times 4 cosine 123 degrees. Okay? Shorter, right? I don't need to write AC square, AB square, ABAC, all those kind of things. No need. This is good enough. And to save that, I'm just going to write this. Okay, so answer? Minus 7.9237. Okay, that's part A. Part B. Now I want to find angle ABC. Okay, part B, I want to find angle ABC. Draw your angle ABC over here. Okay, how to find this angle? You want to use sine rule or cosine rule? OE, what do you use? What? Sine rule. Okay, what is the first thing that you wrote? She wants to use sine rule, huh? Say again? Sine 1, 2, 3. Do we want to do that, or do we want to put the length on top first? Usually we put the length on top first, okay? But mathematically, not much difference. But if you want to be consistent, let us put the length on top first. Okay, so what should be on top first? Because the formula stated in your textbook has the length on top. That's the only reason. If you put angle on top, it is easier only if you are finding angle eventually. But if you are trying to find length, then it will be easier if you put the length on top. Have you noticed that? Yeah, okay. So, yeah, you do have a choice. But if I want to be consistent, I would like to put the length on top first. But if you choose to put angle on top, I'm not going to mark you wrong. Okay? Okay, so if I want to put the length on top, I will have 7.9237 over sine 123 degrees is equals to 5 over sine ABC. Okay, so one equation with one unknown, you will find that sine ABC is going to be equals to it is going to be equals to 5 sine 123 degrees over 7.9237. And you will find angle ABC in 3dp, then round it off to 1dp. Okay, Francis, what do you get for angle ABC? What did you get? Did you do your work? So likewise, you'll be submitting by 3, huh? Those who have done it, angle ABC, what do you get, Darren? How much? 32 exactly. So 32 point. 31.95. 3. Okay. So because in my diagram, I want to leave it as more SF or more dP. So I'll leave it as 3dP first. So your answer over here will be 32 degrees. 32.0 to be exact. Because 1 dP. Okay, next. I want to find the length of AM. AM over here. Part C. How to find? How can I find the length of AM? Shafiq, any suggestions? AM, the highlighted part. Okay, you can, I mean, if you're not sure, you can just suggest first. Then we see whether it works or not lah. Okay, so sign rule, what do you want to write? AM equals A over sine A cannot because it is not perpendicular. You don't think sine rule can? Okay, I want you all to remember this situation. You have a choice between sine rule and cosine rule. You need to choose how to choose. When I was teaching you on sine rule, you don't need to choose because you only learn sine rule. I teach you cosine rule, you just use cosine rule. But in the test, I give you a situation. How are you going to choose? So after this homework, I'm going to teach you how to choose. Okay? So right now we are going to use your cosine rule. Okay? So cosine rule, AM, part C, AM square equals to 4 square plus, how much is BM? It is half of 7.9237. 7.9237 divided by 2 square. Okay, this square plus this square minus 2 times of 4 times 7.9237 over 2 cosine 31.9253. That is our value of AM square. Then you can find AM by taking square root 5SF, then round it off to 3SF. Okay? Moving on. Question 11. Yeah, you go back and watch the video. I will collect this tomorrow. So, question is what about Yang Kun and Francis, right? Tomorrow lah. I give you tomorrow also. Okay, question 11. Oh, by the way, the test is next week. I have told you before the test is next week. It is on, yes I have. And if you are in my Google Classroom, you will see an announcement there. It is in week 5. What? Yes. Oh yes, there is. It will be tested on chapter 6 and 7. It is on Tuesday. Tuesday? Huh? One day, one test? Really? Okay. Listen, your test tentatively is on Tuesday. If there's a need to change, it will be on Wednesday. What? Are you sure or not? Only you. Who's taking history? Then Tuesday, who is taking what? Geography, is it? Okay. Then the next option is Thursday. No? Okay, listen. Listen, class. Tentatively, it is on Tuesday. If there is a need to change, it will be on Wednesday. If there is still a need to change, It will be on Thursday. Thursday is a 1-period lesson. What that means is, it is the first period. Your maths is first period. If you come up late, you have less time for your test. Test is 30 minutes. Okay? So that is for the test. Let me continue. Question 11. I have A, C, and B here. 8, 9, B, 6. Okay. Find angle ABC. ABC. Okay, this angle here. How to find this angle? What is this topic on? Cosine rule. Okay, so Anissa, can you tell me a formula? An equation linking the sides and the angle in green. The rest of you think as well. What is the equation that links the 3 sides and the angle in green? The big hint is cosine rule. So what is it? I already tell you use cosine rule. Yeah, what am I going to write? Say it. BC square equals to, okay, like that. Okay, class, look up at the screen. Is this going to work? I have this side, this side, this side. I have all these. So I have an unknown here, right? I can solve for angle A, but is that what the question wants? What does the question want? Angle B. So I cannot. Using this will not give me the answer straight away. So I need to change it. I need to change this. Okay, so instead of using this, I shall use this angle I want, right? I shall start with AC square first. So AC square equals to AB square plus BC square minus 2 times of AB, BC cosine ABC. Okay, let's look at the difference between these two. AC square, I have it. AB, I have it. BC, I also have it. I have all these. So now I'm left with angle ABC. That's what we want to find out. So this is the one that we should be using. Okay? So do it yourself. Substitute. And solve for angle ABC. Next is part B. Part B, we are trying to find the length of CD. And we would have found angle ABC as... Darren, what is the answer for angle ABC, part A? Who has calculated? Afiq, do you calculate? No. When are you going to calculate? Zafira, do you have the angle? Who has the angle? I wait for your very slow. 40.8 degrees. Okay. So part B, I want to find this length. How? Do you want to use your sine rule or cosine rule or something else? Sine rule. Natasha, what will you use? Sine. Just sine. Just sine, huh? So, this is what Natasha is saying. Sine. Sine what? Huh? Sine rule is something over something equal to something over something. Is that what you have? No. What Natasha has is sine 40.8 degrees equals to opposite, which is CD, over hypotenuse, 8. And then you solve for CD. Good, right? Because she has identified a right angle triangle. So you don't have to use any of your sine rule, cosine rule. Just use sine. So Natasha, be more confident. You were correct. Then you will get CD. CD is equals to 8 sine 40.8 degrees. Now, take note, because nobody calculated this value for me, this is in 1 dp. This rounded off. So in your answers, I want it in 3 dp. Okay, this highlighted portion, I want it in 3 dp. That means this angle, there is a value in 3 dp, then you round off the 1 dp, right? The 1 dp answer is 40.8 lah, which we shouldn't be using for our calculations. So, thank you. This is 40.804. 40.804 degrees. Then you get the answer, 5 SF, round it off to 3 SF. Can? Are you all ready for the summary of how to choose? Why scary? This is something that you need to know, huh? Okay, summary. We always have this triangle, and we always call it for convenience A, B, C. So these capital letters, they can represent the angles as well. So over here, this is angle A, angle C, angle B. Then the opposite sides to the angles will be small a, small b, and small c. Okay? Then I want the area of triangle. What is the formula for area of triangle? You all know area equals to half AB sine C. Okay, is it any length will do? Any angle will do? No. The angle must be, listen to this keyword, the angle over here must be an included angle. Okay, so what is an included angle? Let us look at the two sides. What are these two sides? A and B, right? Where is A? A is over here. A is here. B is here. The angle that is included is in between them. This is the angle included. So in between, what do we have? C. Okay? So I can do the same thing for other sides. I can also call it half BC sine what? Sine A. Let us take a look. B is over here. C is over here. What is the included angle? A. Included in between them. So sine A. Okay? Cannot anyhow choose side, choose angle you like, huh? Now last one. What is the last option that we have? Wait. A, C, sine. So I don't know, right? I'm going to find out. A is here. B is, AC. Then in between them, the included angle is B. Okay? So what is the angle in between them called? What's the name for the angle in between? Included. Yes, thank you. Okay, so that's area. Then I'm going to copy this triangle, because we are going to use the same triangle for our sine rule. Okay, same triangle for sine rule. We have sine A over sine A is equals to, Sophia, equals to what? B over sine B equals to C over sine C. Okay, our sine rule. We all know how to use it, but when do we choose to use sine rule? There are two options. First option is when given two angles and one side. Okay, when you are given two angles and one side, you can use your sine rule. Now, I have a question. When we are given two angles, what else can we find out? Yeah, we can find out the last angle because sum of angles in a triangle. When I'm given two angles, this is actually also, I can find third angle. Okay? When you are given two angles and any side, use your sine rule. Okay? This is the first one. The second possibility when you use your sine rule will be when you are given one side, two sides and one non-included angle. Okay, this is the second case where you use your sine rule. So let's say I am given C over here, A over here. Okay, where is my included angle? If I'm given these two sides, where is the included angle? B, right? But they didn't give you B. Instead, they gave you, for example, angle A. Or they gave you angle C. In this case, you use your sine rule. You can go and check your homework, your 7.3. All your sine rule will be applied when you have either this or this option. Okay? Then, find, non-included will be either angle A or angle C. Because included is angle B. In this case, I give you A, I give you C, included will be in between them. So non-included will be the other two. Okay? And the last one, 2 more minutes. When do I use my cosine rule? Okay, so now cosine rule. Again, there are two cases. The first case, you are given two sides and one included angle. Two sides, one included angle. For example, like this. You're given side A, you're given side C, and they give you the angle in between them. Then you can use your cosine rule. The other situation when you can use your cosine rule is, you're given three sides. That's it. So how many cases are there altogether? There are two cases for sine rule, and there are two cases for cosine rule. If you know these four situations clearly, you will know which one to apply. Once you know which one to apply, you can get the answer. These are the only four things you need to know for your sine rule and cosine rule. Okay?